use the abacus, this is what we're doing. Now, if you see, we're going to count 1, right? Because we counted 1, we can do 2. How does that look? Oh, okay. So let's go back. Well, we have 0. Notice that this is an abacus. This abacus has the top beads. Here's my top beads, and then here is my bottom beads. The bottom beads is anything underneath this horizontal bar. So when we're looking at this is what we call what do we call this? This is what we call a horizontal bar or a reckoning bar or a beam. I call it a beam. I don't know. There could be a more professional name. I don't know what it is. A more technical name than just a horizontal bar. But anyways, this is what it, and then when we count it, we're going to add 1. When we have 1, you'll notice that we have 1. Oh no, that's what 1 looks like. 1 looks like that. When the beads are touching this horizontal bar, when the beads are touching this beam, this is what's being counted. That's what we call 1. Now we have 2. That's what 2 looks like. 2 has 2 beads, just as how we have 2 items. I don't know. So then that's what 2 is. 3 just looks like that. 3 beads, 1, 2, 3 is touching the horizontal bar. And then we have 4. 4 is that. 4 is that. So what we're looking is we have the horizontal bar. This is the horizontal bar, and then this is 4. Now notice if I do this, this is 5. 5, sorry, let's see, 5. So these are all the activities in the book for those children that are usually preschoolers. So I'm looking at like, what do you call it? I'm looking at not third graders, 3-year-olds, 4-year-olds, and 5-year-olds. And then when we look, we have 5. That's what 5 looks like. 5. So we have 5, and then we could do 5, 5, 5, 5, 5, 5. These are all 5s. And then we have 6, but notice we have 5, 5, 5, 5, 6, right? And then we have 5 and 5. So this is 6. We could do all of these are 6s, and then we can have 7. Now, 7 looks like that. In comparison, 7 has 5, 6, 7. 5 bead, right? This is the 5, and then 2 beads on the bottom. This is considered 7. Together, they're considered 7. So in comparison, these are all 6s, and this is 7. So if I move this all up, now they're all 7s, and now we have 8. Because we have 8, again, in comparison, these are all 7s, and then this is 8, and then these 2 are 7s. And then if I move everything up like that, this is all 8. These are all 8s. And then we have 9. These are, no, this is 9. This is 9. Because this is 9, these are all 8s. And then when we look, I'm going to move all of these up. Now they're all 9s. When I zero it out, that's what 0 looks like. Just to review, so this is a 0, and then we have 1. Because we have a value of 1, and then we have 2, we have 3, right? We can do 3. So if I did all of this, this is all 3. And then if I have 4, that's what 4 looks like. And then I move everything up. These are all 4s. And then 5 is this. 5 is this. 5, right, is the top bead. The top bead will always be 5. So if I move all of these beads down to the horizontal bar, these are all considered 5. Now we have 6. 6 looks like that. Whoa, 6 looks like that. And then we have 7, right? So these are 5. So 5, and then this is 7. So 2 beads here, and then here is 7. 5, 6, 7. 5, 6, 7. And then if I'm going to move all these beads up like this, we have all of them are 7s. Now we have 8. 8, 7, 7, 7, 7, 8, 7, 7. And then we're going to go move these ones up, and now we have 8. And then we have 9. 9, we'll do 9 here, right? So what's after 9? Well, these are all 8s. These are 8s, so I'm going to move them all to 9. So this is 9. 9, 9, 9, 8, 9. Now we're at 9, and then this is 9, 9. Okay, well, what's going to happen is, well, what do you do with 10? Well, this is where place value comes in. If you look, every column is a place value. Ones, tens, hundred, thousands, 10,000. And when we have it, we have our ones, our tens. When we count, we do 1, 2, 3, 4. And then we do 5, 6, 7, 8, 9. Because we have 9, now we can talk about 10. 10 will always be here. 10 is here. Why is 10 here? The reason why 10 is here is because I have a dot here. Because this dot is my ones indicator. It's a label to tell me that this is my ones. That's what I do here. Now, if you choose, there's another dot here. You could choose that one over here. If you choose that one, then you're going to move all your ones to here. So you have your ones. So it'll be 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9, and then 10. 10, 11, 12, 13, 14. And then we have 15. Make sense? So after 15, right? 16, 17, 18. And then because we have our ones, our tens, we don't have any beads. We don't have any more columns for hundreds. That's why I decided to choose. That's why I choose this one over here. Because now I have my ones, my tens, my hundreds. I have enough room for hundreds, thousands, and 10,000s. So if we were to look at this year, it'd be 20, 20, 25. That's this year. That's what this year looks like on the abacus. Let me see if I can write it. When we're looking, we have 20, 25. 20, 25. How are we doing? Any questions? Your voices are startling. Oh, miracle. It shouldn't be too loud, right? But it should just be enough just to like bump it up a little bit. I know some other people are like, "Oh my god," and kind of like, but I'm trying to make sure you guys are not sleeping. Bro, I don't know. Too much. Yeah, I got muted last live for that. Okay. So, Miracle, how's it going? Yeah? When we're looking, we want to look at how we read the abacus. Are we ready for, I don't know who else is here other than okay, but what does the poll mean? Okay. Um, if you're going to continue to just talk, so then we're looking at ones, tens, hundreds, thousands, and 10,000. And then notice we have decimals. I bought another abacus for it. Yay! That's awesome. Well done. Good. And is it single color miracles? Right? It's a single color, yeah? Yeah, it can be if you can find it. But yeah, as long as it's single color. Because I looked at some other people and they had like the multicolored that's 13. Ooh, doubles on top. Again? You got that one? You got this one. Didn't you tell me that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one's only 11. Yeah, yep, yep. So when we're looking, right, you can still count. Oh, did you know you could do 6 times table? This is really cool. 6 times 1 is 6. 6 times 2, add 1, add 5, add 6, right? Did I tell you this? How to do 6 times table? 11 column and one. Oh, I see. Did you find it at the thrift store, Miracles? That's really cool. That's really cool. I'm surprised that you can find them. I can't find them anywhere around my neighborhood because I keep looking, but I can't find them. This one just happens to be gifted to me because a retired abacus teacher, an abacus teacher was retiring, and the abacus teacher didn't need them anymore. So this is why I got this one. But if it wasn't for them, I couldn't find it, and I didn't want to pay for it. But that's really interesting. And then don't forget to label your dot, your ones indicator, so you know where your ones is. And then don't forget, right? And I usually keep it at least the 2 columns here, so you could do decimals if you choose to have that. Yes, yeah, you're very lucky. So okay, cool. Let me. Yeah. I mean, it's just you and me. What do you want to talk about? Do you want to do some more adding and subtracting? We can practice some adding and subtracting. I don't know if anybody else is here. If anybody else is here, oh, I gotta go back to this. I was just cleaning up some of my stuff. Oh, I have a lot of stuff. Now I'm just here kind of hanging out. Oh, but it's really cool. Okay. Yeah, I think it's just you and I. So what do you want to do? Do you want to do adding and subtracting? Double digit, single digit? I love to get some adding and subtracting and regrouping. Canadian discovered. Okay, let's do some adding and subtracting and regrouping. All right. So, yeah, I mean, if it's just us, then might as well, right? Might as well make the most of it and useful. Regrouping. Let's see. So we can start going into this one, and that's what this book is. This book is about regrouping. Oh, maybe I'll move this. All right. Okay. Do you remember how to add the six? Oh, hello, AI TikTok God. Welcome back. You are here. Thank you so much. I appreciate you. You know what? At least you're not like a spam. Let's do one to refresh. Okay. So this one is we're understanding. At least you're not a bot, AI TikTok God. All right. Um, we're going to remember. Can we add it to this one? This one is a little bit. The reason why is what? Because the question is always going to be, can you add it? Right? If I have one, I'm going to add the six. Is there enough to add the six? Yes, there is. Right? So I'm going to add the one. I'm going to add six. So I have five and six. And it's again here for two. Two plus six. Is there enough? Yep. I'm going to add this. Right? Thank you, Miracles, for the confetti and the heart me. And then again, so I did hear, so I wanted to make sure you go critical where you think about, what we're trying to do. So here we have three, and can we add the six? Yes, we can. But this is where it gets a little tricky, is we want to add the four. When we add the four, we need to add the six. To add the six, what are we going to do? We know, right? We know that the partner of six is four. Because we know partner of six is four, we're going to isolate it, right? So six is equal to plus the 10 minus four. Now, if you notice, we do 10. Remember what 10 looks like? One and zero. One and zero. That's what 10 looks like. So when we have four and we want to add 10, it just means one, zero. One, zero. And then we remember we need to minus the 4. Now we're going to take away the 4. Our final answer is 15. We can do, you know what? We could do the 5. When we do the 5, it'd be the same thing, right? We remember that our formula is how to make a 5. 5 plus 5, right? 5 plus 5 is equal to plus the 10 minus the 5. So what are we going to do? We're going to plus the 10 and minus the 5. We have 6. So on my abacus, I'll show 6. I have 6. I want to add the 5. To add the 5, what are we going to do? We need to plus the 10 minus the 5. So we're going to plus the 10, 1, 0, 1, 0, and then we're going to minus the 5. So my final answer is 11. That's what we're doing, is regrouping. Oh, let's do subtraction. Let's do subtraction. So when we're doing subtraction, it would be 15, 16, right? 16 minus 7. Oh, good. Oh, good. Minus 7. How do you minus the 7? Do you remember that, Miracle? How do you minus the 7? Oh, I need to show you the number. Let me show you my number. Sorry, I forgot. I did. What's the question? It was 12 minus 7, right? So if I have 12 and I want to take away the 7, do you remember how to take away the 7, Miracles? Minus 7. Do you remember how to minus the 7? Remember that the partner of 7 is 3. Minus 7 minus 3 is equal to minus 10. That's the partner, right? 7 and 3 are partners. So remember, we isolate the variable, we isolate the 7 is equal to minus the 10 plus the 3. So what are we going to do? We're going to minus the 10 plus the 3. We're going to minus the 10, plus the 3. Still learning. Hello, Angela. Still, right? Minus the 10 plus the 3. What is this? This is now a two-step, right? Minus the 7 is equal to minus the 10 plus the 3. Remember, I cannot take away the 3. I'm not going to, cannot add the 3. So do you remember how to add the 3? We're going to plus the 3 is equal to what? Plus the 3 is what? Plus the 3 is, plus 3 plus 2 is equal to 5. Plus the 3 is equal to plus the 5 minus the 2. So we're going to plus the 5, right? Plus the 5 minus the 2. So hey, Cody. Easy, Cody. Hurt people hurt people. Who hurt you, Cody? So when we're doing it, we're doing this. Right, Miracles? Is the two-step too much? Because what we're doing is we're substituting this. This is a good one. I'm lost. Okay, so let's go back. Let's go back. We do 7. We do 12, right? Did you add 12 to your abacus? I hope 5th graders aren't learning. Oh, hey, undercover. Who hurt you? So when we're doing, right, we minus the 10, so we know we have to take away the 10, right? How do you remember what's the formula to minus the 7? You hurt my brain. Hey, calm down, both of you. Maybe you guys are twins. That's fantastic. You guys, I don't know if you guys are, how old you are. I mean, if you're young and you have kids, then anyways. So miracles, do you remember the formula for minus the 7? Right? So the minus the 7. So what do? We minus the 10, right? So we take away the 10. And then what do? We add the 3. That's so good, Cody. I'm so proud of you. I'm so happy you could do it. But that's not what I'm looking for. Right? So what we're going to do is we're going to minus the 10 and we need to add the 3. So when we add the 3, what are we going to do? We know what? We know that we're going to plus the 5 and then take away the 2. Mute everyone who is rude, please. It's okay. They can be rude. They're just hurt and they need to be talking. They want to be heard. But we want to add the 3. Do you notice that? Can you add the 3 here? So what are we trying to do? If we're adding the 3, do you remember how to add the 3? We got to go back to the 5. Can you add the 5? If you can add the 5, what would be the formula? To add the 5 would be plus the 5 minus the 2. So I'm going to plus the 5. I'm going to take away the 2. So then my final answer is 5. Yes. That's all. Yep. There you go. So then your final answer is 5. Make sense? So you take it one step at a time, right? So what we just did is we went a little bit. But that's why you break it up. That's why I break it up. I do this one and I do this one. Yeah. One step at a time, one number at a time. Don't go too fast, right? You go slow. You do one step and you go critical think. You think critically, what are we trying to do? We add the one. Can you add the one? Yes, we're going to add the one. Can you add the three? Yes, we can add the three. Then add the three. So remember, there's a formula, right? Wait, there's a whole framework. It's always, is there enough beads? Yes, yes. When you're working with abacus, it is a different way of thinking. It's always about, can you add the three? This is probably only taught in China. Yeah, apparently you're not very open to a lot of things. No, you're right. It's taught in India as well, and Finland, and France, and Germany, and South America. It's just not American. So, undercover, I feel sorry for you. Okay, I'm really enjoying this because it's new to me. Yeah. Oh, yeah. Don't worry about it. Okay. So, what we're going to do is, do you want to do another one? We can do another one. Um, there's a few people. Let's do a little review. Let's do a review. If you're in Germany, then don't be rude because it's not only in China. So, if you live in Germany, it's in German because I have a few people that are interested in learning this as well. Okay, so let's do a review. Why are we spreading misinformation? Oh, is English your first language? Oh, sorry. Okay, so let's do a review. We're going to do one, two, three, four. Because this is four, there's the horizontal bar, right? Because we're in contact with the horizontal bar, we're going to take this away and we're going to add the five. When we add the five, we're going to do five, six, right? Six, seven, eight, and nine. So after nine, we have 10. We have 10. How do we know this is 10? This is 0 and 1. 1, 0. Because we have 1 and 0, now we can do 11, we can do 12, 13, and 14. Yep. Easy, easy. So when we do 14, we do 15. And then have 16, 17, 18, 19, and then 20. It's okay, Miracles. Apparently, Undercover doesn't know doesn't know how to count. That's okay. You don't need to comment. So if we're done here, it'd be nice to go in order along with the book. Oh, okay. It would be nice to order this along with the book. Well, which book are you talking about? Hello, Angela. Thank you for commenting because I don't know who else is here in the room other than Undercover. And apparently, Undercover has a mom. I don't know. But apparently, this Undercover has not been taught what being polite is. All right. So, yeah, because no, I understand. Which one though? Are you talking about the first book? So we're talking about the first book. So let's do this, right? Do our Let's do this. Let's see the book. So are you talking about this one? Well, this one is for young kids. So what I did is I was thinking about young kids about adding and subtracting. So we can do that. Let's do that. Thank you for commenting. But yeah, we could do it in order, just so you can understand what's going on. In the beginning of the book, we talk about the structure of the abacus. And so we talk about the bottom beads and the top beads. If you want to be poetic, you can talk about the heaven beads and the earth beads. And then we're going to count again. So let's do a little review. We have 0. Because we have 0, none of the beads are touching the horizontal bar. So then we have 1, we have 2, we have 3, we have 4. So because we have 4, now if you notice, this is all 4. You might be wondering why, right? You might be wondering why I'm here. Well, I have this indicator. This is my ones indicator. Because of my ones indicator, I can go here or I can go here. If I choose this one, right, I have my ones, my tens, my hundreds, my thousands, my 10,000s. And then what happens, let me send some Chinese people that would love this. Sure. Anyways, so you could choose this one over here, right? If you choose this one, yes, you could choose any one. You're exactly right, Miracles. So here, if I did this one, my ones, now I'd have my ones, my tens, but notice I don't have any room for hundreds. So when we're looking, we have 1, 2, 3, 4. We can do 10, 20, 30, 40. Make sense? And then, but I'm going to go back to here. So I'm going to go back to here. Because I go back to here, I have my 1, 2, 3, 4. And then we can go into how to add the 4. When we go into after 4. After 4 is 5. This is the top beat, 5. So we have 5, 6, 7, right? 7. How do I know? Now we can decompose. Because what? 5, 6, 7. 5, 6, 7, right? 5 plus 2 is 7. And then I can add 3. 5 plus 3 is 8. And then what happens? 5 plus 4 is 9. So now we can do is we can decompose. You might be wondering, well, what about 10? 10, just as we have a place value, is a 1 and a 0. Because a 1 and a 0, right? That's what 10 looks like. 10 is this. Just as we write it. Just as we write, we have 10 and a 0. We have 1 and a 0. I'm sorry, 1 and a 0. And then after 1 and a 0, we have 11, right? We have 11, 1 and 1. And then we have 12. 12 looks very familiar, doesn't it? Because what? 1 and 2. When you're joining numbers, you're decomposing. Yes, yes, exactly. So as you move the beads, you're composing each of the beads. Oh, good, Angela. I'm so happy you're here. Right? So now we can count by tens. So we have 10, 20, 30, 40. And now we can talk about place values because it's very easy. And then we have hundreds. We can count by hundreds. So we have 100, 200, 300, 400, and then 500. After 500, we have 600, 700, 800, 900. And then obviously we have 1,000. And then when I look, we have 20, like we have the year 2025. Yeah. So this is about learning how to read the abacus. The first thing we all need to do is understand how to read the abacus. Why? Because once we learn how to read the abacus, it's very easy to what's going on. So uh, here is a book. If you're looking at a abacus maze book, what I did is I created a maze so we can start looking at the beads. Here is a bead. Tell me in the chat what number you think this is. So if I have my tens and my ones, I have my tens and then I have my ones. What number do we think this is? What number do we think this is? 15. Ha ha ha, miracles. 15 would look like this. 1 and 5. 15, that's what 15 looks like. 1 and 5. Yes, thank you, Jeffers. It is 55. Yep, because it's 5 and 5. So we want to remember that the top beat is 5. So we have 15, 55, and then we have our next number. So if I have my tens and I have my ones, I have my tens and I have my ones. It's attention to detail. Thank you, Jeffers. So we have our tens and our ones. We have our tens, we have 1, 2, and then we have our ones. 1, 2, 3, 4. Make sense? Thank you, Jeffers. Angela, are you still with me? Thank you, Miracles. So we have 24, and then we're here. All right. So what do we have? We have our tens and our ones. If this is my tens, and then this is my ones, what number do we think this is? My tens and my ones. So if I look, yes, it is 97. Thank you, Miracles. Wait, how do we get that? 5, 6, 7, 8, 9. And then what? 5, 6, 7. So we have 97. And then we have to go over here. Because we go over here, right? What we're doing is we find the answer and then we follow the square. Because we follow the square, we can go to the next question. So I have my tens and I have my ones. If I have my tens and I have my ones, and that's it. What number do we think that is? Haha, miracles. We have to do the, don't forget. There you go. Thank you, Jeffers. Yes, we have tens is 1, right? And then our ones. This is 6, 5, and 6. So that's 16, and now we're here. Now what are we going to do? We have our tens, which is this. And then we have our ones, which is over here. What number do we think this is? Thank you, Jeffers. We do. We do have 45. Almost, Mr. Steele. Mr. Steele. So 11 would actually look like this. 11 would look like 1 and 1, just as how you've written it. When we're looking, I'm wondering how these work. Oh, thank you. No, thank you, Jeffers. I appreciate your comments. So he's faster than me. It takes a little bit to understand. So, Mr. Steele, this is what 111 looks like. What we mentioned was this. This is 40, and this is 5. 1, 2, 3, 4. This is 40, and then this is 5. So all the top beat is 5. Lucky says 12. 12 is actually 1 and a 2. And that's incorrect because that's not what we have. Oh, so we have 1 and 2. That's what 12 looks like. Okay, this number should be easy. We have our tens, we have our tens, and we have our ones. If we have our tens and our ones, what number do we think that is? 99. Yep. Good job. Well done. Well done. 99. So it's different than 88. And then we have this one. We have our tens, we have our tens, and we have our ones. So we have our tens, and then we have our ones. Great. Thank you, Jeffers. So we have 5, 6, 7. And then we have 5, 6, 7, 8, 9. Thank you, Miracle. So 79, and it takes me to here, right? I have my tens and my ones. So if I have my tens and I have my ones, 67, 5, 6, and then 5, 6, 7. Well done. 67, and it takes me to here. So we have our tens and our ones. This is my tens and my ones. Wow, Jeffers, you're very fast. 87. Yes. 5, 6, 7, 8, and then 7. 5, 6, 7. Great. All right. 87. What do we have here? So if my tens is this, and my ones is this. Thank you, Jeffers. How are we doing? Hey, Ileana. Welcome, welcome. I'm moving my bead. Ah, good job. Yeah, it's always good to move it, right? You want to be able to practice. Thank you, Ileana. It is 27. It's 2, this is my tens, and this is my 7. 5, 6, 7. And then I'm over here. Oh, you can't see that. There we go. So what do we have here? We have my tens, which is this, and my ones. This is my ones. So I'm over here. What number? Yes, thank you, Ileana. I'm so confused. Well, when we're looking, we have 3. 1, 2, 3. Does that make sense? Cot addition. Does that understand? Do you understand? This is 3. 1, 2, 3. When we're looking, we have here. This number is a value of 5. So we have 5, 6, 7. So when we put it together, it's 37, just as Miracles mentioned and Ileana. When we have this is 7. We have 8. We have 9. Let's start over. We have 1, 2, 3, 4. And then 5. The value of 5 will always be top. We have 6, 7, 8, and then 9. After 9, there's 10. 10 is 1 and a 0. And then we can do 11. So we're going to continue on with 37. Oh, we're our final answer. So it does go by place values. Yes. Every column is a place value. Thank you, Ileana. That's a good question. Every column is a place value. So when we're looking, if I have my top bead, right? This is my tens. This is my ones. What number is this? If I have my tens and my ones, when we count, right? We can start from 5. The 5 will always be the top bead. So we have 5, right? Thank you, Ileana. Yep, 5. Ah, you forgot the 5 at the top. So when we're looking, it's 5 and 5. 5, 6, 7, 8, 9. Don't forget the 5 on top. 54 looks like this. 5 and 4. 1, 2, 3, 4. Right? But if we add the 5, now we have 9. 5, 6, 7, 8, 9. Yeah? Hey, Neon! Right, Angela? Does that make sense? So what abacus does, it helps with attention to detail, right? Because all it is about the positioning. It's not the colors. It's all about the position. So if the top bead touches, right? If the top bead touches the horizontal bar, that's what's being counted. Why do those add up to don't three? Interesting. I was so close. You were so close. Yes. Oh, Oh, the reason why I'm over here is because I want to use this as my ones indicator. I have a dot. This is my ones. It's a label, right? If you notice, I have 2 labels. There's one here, there's one here. I can choose any one. Because I chose this one, right? I can do ones, tens, hundreds, thousands, 10,000. However, if you choose this one over here, then you have to move it all over and you do your ones and your tens. But then notice there's no room for hundreds. So when we're looking, that's why I'm always over here. Now, what happens if I'm over here? Well, now I have room for decimals. Because remember, a decimal is after the ones as the decimals. And so now we can do, let's say, money or anything after ones. And now we can do decimals on the abacus. We can do, because after the ones is a decimal, but notice it doesn't sit on a place value. It sits between. Then we have our tenths and then we have our hundredths. Yeah, no, thank you, Hohen. Thank you for the question. But that's always a very common question because and that's in it's because people don't see. Oh, and that's the other thing is if you notice because I have my ones here, my another label is over here. My other label is here. Because my label is here, I know I can just go to here and this will be my thousands. So now I can go ones, thousands. And it's the same thing with the bigger abacus. So if I have a bigger abacus like this one is a 13 column abacus, right? I can choose this one, but notice I have a label at every grouping. So we have our ones, our thousands, our millions, billions, and then trillions. So that's why the indicators are just labels. And you can choose any one of these dots. It doesn't matter. They're not movable. That's why you got to choose which one you want. But because we're choosing this one, then we have a lot more room for our number. However, if I choose here, then I only have this much to go through. Make sense? Okay. So, then the other thing was, so this specific one, let me see if I can, um, there we go. Um, yeah, I can't believe they didn't use these in math class. I don't know where you are, but it's not a very common math tool because teachers don't know what it is. That's why I'm here. I'm here to help you guys, to teach you guys so I can live vicariously through you guys and you guys can live vicariously through your children if you choose to introduce abacus this way. So that's the one thing, is understanding how to move the beads. When you understand how to read the abacus, then we can go into how to add and subtract, multiply and divide. So this right here is what I called a reverse maze. And inside this is a maze, my maze book. And in my maze book, what I did, oh, I bought the book. Oh, fantastic. Fantastic. So if you notice, I have the 53, 54, I'm sorry, 54. And what you're going to do is you're going to color it in. Thank you. No, thank you. I appreciate that. Let me know if you have any more questions. So then here is the instructions, right? If I have 54, I want to color it in. So I'd color in 54. And then I move to here. So I give you the path, right? Because I give you the path, you're supposed to color it in. So here is 96. So this would be 96 when I color it in. The idea is to make it a little bit interactive, and that's what it would look like. So I have 54, I color it in. I have 96, I color it in. And then I have 29, I colored in. So I give you 17, you just have to color in 7, 1 and 7. So it's kind of a reverse, but making sure that we all understand how to read. That's what this reverse maze is. And then after that, okay, so we did this, we did that. Okay, so the first thing we're going to do is we're going to also understand how to move the beads. If you notice that the beads are edged, right? There's an edge to it, so you want to use your fingers, the edges of your fingers, to move the beads. You don't want to be aggressive. You want to be gentle. So when you're gentle, you want to be happy. The reason why is because if I have my number and I do this, then that means I flicked too hard. Don't flick too hard, because if you flick too hard, then your answer will be wrong. So when you're looking, right, if I have 5, I want to just intentionally move the 3. So then it'll give me 8. What we're going to do is, so that's what this is. And then notice that if you bump your abacus, you're going to get the wrong answer. Use your left hand to hold the abacus. So then it stabilizes and you're able to move the beads. That is the other thing. All right. So what we're going to do is we're going to continue on with learning how to add and subtract. The first thing we're going to do is understand in abacus world that we focus in on the add-in. What does that mean? The reason why is because we don't want to focus what the result is. One of the things about the result is we don't want to know 1 plus 7 is equal to 8. What we want to do is, can we add the 1? So my question starts with 7. My next number is, can I add the 1? We need to know if we can add the 1. If we can add it, so we're going to add the 1. My final answer is 8, right? So what's going to happen is we always want to look at the add-in. It's the same thing with the 2. When we do the 2, let's do 2, right? We have 5. We add the 5. Can we add the 2? Yes, we can add the 2, so we're going to add the 2. And my final answer is 7. Again, it's a different way of thinking. It's different than what we teach in mainstream. Mainstream school, we always look at the result, but it's not the case for abacus world. In abacus world, we want to know what the add-in. You could, right? You could, when we look at it, it's very easy to see. So if I have the number 5, right? I have my question 5, and I want to add the 3. I'm going to add the 3. I know my answer is 8. You could do dots like the mainstream, but then you have to count it all. 1, 2, 3, 4, 5, 6, 7, 8. It's a lot of counting, as opposed to supertizing, right? In abacus, we can supertize what 8 is. 8 looks like that. If I did this, we know that 9 is that. How do I know? Because every column will always be 9 no matter what. You can supertize. What is supertizing? Supertizing means that if I look at my number, I know that this is 7. I don't need to count 5, 6, 7. That's what that means, right? And it's the same thing with the 4. Now, if you notice, we add the 4, we add to the horizontal bar. When we subtract, we move it away from the horizontal bar. So when we're looking at the 1, it's the same thing. We add, we have 7 to the abacus, to the horizontal bar. Now, when we subtract, we want to move it away from the horizontal bar. So my final answer is 6. Can we do it? Yes, we can take away the 6. So we don't have a separate strategy to add. What if we can add it, we can subtract. So it's just the reverse. And that's the one thing about the abacus that shows you that when you add it, you can subtract it. So if I add, I go to the horizontal bar. I added 4. Now I want to take away 3. To take away the 3, I just remove it away from the horizontal bar. So my final answer is 1. And I'm just moving the beads just to show what it looks like, right? We add the 4, take away the 4. There's not a whole lot there. Now we have the 5. No, we don't have 5. We have 8. Again, 5 is the same. When we add the 5, we bring it down. When we take away the 5, we move it away from the horizontal bar. So here's the question. If I add the 6 and my 1, I want to add the 6, I go 5, 6, I'll bring it together like that. If I want to take away the 6, I move it away. See, it's the same thing. So now we're seeing is a number pattern. When we add the 6 and we take away the 6. And then we do it again for the 7. We have 7. We have 1, and we add 7, 5, 6, 7. We're going to bring it together like that and then take it away like that. Anybody have any questions? I'm just going to keep going through. We add the 9, we take away the 9. That's not a whole lot. All right, so we're done with the simple. This is what we call simple. Means, what does simple mean? Simple means that there's always enough beads. So what's after this is what happens when there's not enough beads. Oh, good, Angela. Good, good, good. Let me know if you have any questions. So the first thing we're going to do is understand. What are we going to do? We're going to understand how to make a 5. Why? Because the question is, what happens when there's not enough beads? You can count, right? So here's the question. The question is 3. So we have the 3, and I want to add the 4. We can count, right? You could count 4 items. You could, right? If I have 3 pencils and I need to add 4 pencils, yeah, you can add them together. You could do that. Or you can have critical thinking. What does that mean? Well, we're teaching children this concept of how to make a 5, right? When we're making a 5, why are we teaching the kids how to make a 5? In abacus world, this is very critical. This is one of the pillars that we are doing. So here is a question. If I have 3, I'm going to have 3. Because I have 3, I'm going to have 3 pennies, right? If I have 4, I have only a nickel. I have 5 cents. Because I have 5 cents, I have enough for 4, but I only have it in, so I need change back. So what's going to happen? What's going to happen is I have 5. That's too much. I need to take away the 1. So my final answer is 7. If I add the 5, I added too much, right? I need to take away the 1. So my final answer is 7. Why don't you use, oh, the reason why I'm over here is because I have a ones indicator. This dot, if you see, is my ones indicator. This ones indicator just tells me that my place value. So I'm so excited. Oh, Principal Martin, I actually sent you an email for your address. Please let me know what your address is in the email so I can send it out before today. I can send it out today if you give me your email, if you give me your shipping address. Principal Martin, thank you so much. I appreciate that. Hey, Jeff the land shark. Hello. So, Don, did that make sense? Why we're here is because we're at the ones place. You could choose this dot. There's a dot right here. So if you look at the dot, you can move everything over like that. And there'd be ones, tens, and then there'll be, right? But there would be no room for hundreds. So every column is a place value. Every place value, right, only goes to 9. So we do 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. So these are all 9. Yes, thank you. No, thank you, Don. So your number had your username is 710, right? 710. I know these are typically bigger. I know these are typically bigger as well. So the blue beads. So the non-blue beads are each one. The blue beads is a value of one, value of 5. So all of these are 5. The bigger ones, like this, I know these are typically bigger as well. Like this. This is a Chinese abacus. This is a standard size soroban, which is a Japanese abacus. If you're talking about more columns, then there's 13 columns, right? With the 13 columns, you can just do more beads. You can just do more digits. Kien, Kiani, I don't know what that means. So the non-blue beads are on each. Yes, the columns. That's what I meant. Oh, okay, yeah. The more columns, the bigger the number, right? That's all it is. That's all it is. But you could still do small numbers on this one. Yeah. Cool. Okay, so we're going to go back to understanding how do we make a 5. The reason why is because we don't have enough beads. The interesting thing is when we don't have enough beads, we can actually start talking about substitution. When we have the 4, 1, 2, 3, 4, we have 4 on the abacus. If I have 4 pennies, right? I have 4 pennies on the abacus. I have 4 pennies. But notice if I give you a 5, it's enough, but I need change back. So I'm going to give you the 5, but I'm going to take away the 1. It's the same thing on the abacus, right? On the abacus, if I give you 5, I'm going to take away the 1. So my final answer is 8. And the difference is we are now starting to utilize functions and procedures and formulas. So the kids will start understanding how to formulate and critically think. Angela, are you okay? Are you here still? Did that make sense? Yes. Okay, good. So after understanding how to move the beads, it would be understanding how to add the 5. After adding the 5, right? We can do it again. This is how versatile adding the 4 is. Adding the 4 is very versatile. Why? Because when we have the 2 and we want to add the 4, right? Adding the 4 again, I only have a nickel. I only have 5 cents. So I'm going to give you my 5 cents because why? I don't have enough beads to add the 1. I'm sorry, we don't have enough beads to add the 4. So we're going to add the 5 and we're going to take away the 4. So what we're doing is we're doing substitution. So it's very similar to algebra, right? But it's the beginning steps of algebra. We don't do algebra in abacus, but we do the beginning steps. So if I had 2, right? If I had 2, I'm going to go back and I'm going to review. When I have 2, I don't have enough beads to add the 4. But I have a nickel. This nickel is what? I need change back. So I'm going to add the 5 and I'm going to take away the 1. So my final answer is 6. Pro Club, welcome back. Welcome back. How's it going? Always sharp. All right, we can do it again. We can do it again with the 1. If I have 1 on the abacus, but again, I only have a nickel, right? If I only have a nickel, I only add the 5. That's where I'm at. But that's too much. So I'm going to take away the 1. Are the blue 5? Yes. The top bead will always be 5. So when we're looking, the top bead will always be 5. So if we review, this is 5. Now we have 6. And then we have 7. We have 8. And then 9. So all together is 9. When we are looking, we have 1, 2, 3, 4. And then we have 5. Whoa, 5. 6, 7. 5, 6, 7, 8. 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. Did that make sense, Chief? Okay. So what about 3? We can do it with 3. What do you mean? Well, again, we're not going to memorize our doubles, right? Then 10 would be ha ha ha. No, because if you think about it, if the top beat is 5, right? This would be 55. 10 would look like 1 and a 0, just like 1. Does that make sense? So when we're looking, we have 1, 10, 100, 1,000, 10,000. Oh, but it's so funny. A lot of people think that this is 10. This is 10. No, that's just 5 and 5. Every column is a specific number. Every dot, every column is a specific number. So if I did 9, this would be 99. This is 999. Yeah. No, you're absolutely right. Thank you. I appreciate it. That's funny though, right? And yeah, I don't know why people think that, but it's 5. The value of 5, right? This is the value of 5. Together, it'd just be 5 and 5. If yeah, when we do 10 to do 5 plus 5, that's actually a formula, and that's when we have to figure out how to make a 10. Yes, they're assigning a number. Okay, so it helps you understand. Yeah, yeah. I don't show this until later because a lot of people are not thinking. Not they're not thinking, but they're just absorbing what's going on. So I don't show this until a little bit later. But it's always helpful afterwards because it gets your mind thinking. And then when I add it, everything places together. All right, cool. Okay, so we could do it again. Remember, we're not going to memorize our doubles. What we're going to do is we're going to utilize the 5. So if I have 3 on my abacus, I have 3 on my abacus. I have 3 on my abacus. I don't have enough beads to add the 3. So what do I do? Because I don't have enough, but guess what? I have a nickel. I have this 5 cents. This 5 cents, I have enough. Because I have 5 cents, I have enough. I'm going to give you my 5 cents, but then I need change back. So I'm going to give you my 5 cents. I need change back. And I got to take away the 2. I need to take away 2. Why? Because you're only looking for 3. When I'm looking for 3, I need some change back. So I take away 2. Yeah. So what we're doing is we're understanding these concepts. We know the pairs. We know that 4 and 1 is a pair, and 1 and 4 is a pair. 3 and 2 is a pair. These are things we're going to have to remember. We're going to have to remember this concept. This concept has a formula, and we call this in abacus world. We call it a formula. We can do it again. We have 4. When we add the 4, okay, if I have 4, right? I want to add the 3. Notice I don't have any more beads to add the 3. Abacus formula. Thank you, Carter. Yes, abacus formula. So what's going to happen is what? I have a nickel. I have 5 cents. To have 5 cents, I'm going to give you my 5 cents, right? But notice that's too much. So I need to take away 2. So if I give you my 5 cents, I'm going to take away 2 cents. So what do I have left? I have 7 cents. Make sense? Ha, makes sense. Carter. How's it going, Carter? Yeah? Well, we could do it again. But now you're going to start seeing there's a pattern. If you notice when we add, right? We add we plus the 5 minus the 2. When we subtract, we're going to do the opposite. We're going to minus the 5 plus the 2. So now we're understanding how to add and subtract. Now we see a number pattern. We add it, we subtract. We add and then we subtract. So what does that mean? It's always the 5 that we utilize, right? Cool. All right. We could do 2, but 2 doesn't have a lot of questions. 2 only has 2 questions. Why? Because 2 plus 2 is enough. 2, is there enough beads to add the 2? Yes, there is enough beads to add the 2. So we don't need to use a formula. So we just add the 2. That's why you have to start thinking critically. You have to critically think, what can we do? Can we do it? Yes or no? So here is 3. If I have 3, can I add the 2? No, I can't. So if I have 3 and I want to add 2, but I don't have enough beads, right? I'm going to give you my 5 cents, but I need change back. So I'm going to take away the 3. So it's the same thing. I give you my 5 and I need change back, which is 2. Hey, Carter, where did we leave off? Was it adding doubles? 2-digit numbers? I don't remember anymore. Okay, so we can do it again with the 4, right? 4 plus 2. So we have 4 plus 2. There's not enough beads to plus the 2. The reason why it's nice to have the abacus is so then we can try to figure out how to move our beads. If you're given a blank page, right? Then the sky is the limit. Then it's harder to figure it out. But if you're given a constraint, then we know what our boundaries are. So if I want to add the 2, I have a nickel. Because I have 5 cents, what am I going to do? I'm going to give you my 5 cents. That's too much. So I'm going to take away the 3. So my final answer is 6. 5, 6. So I'll do it again. We add the 5 and we take away the 3. That's the abacus formula. And now we're left with 6. Cool. Anybody have any questions? Okay. So that's the abacus formula, plus the 5 minus the 2. And then we can do it again with 1. But the problem with 1 is that it's only the one number. So it's exactly what the formula is. If I have the 4, then what do? I need to minus the 5, take away the 1. So I minus the 5 and I take away the 1. My final answer is 5. And then that's it. So this one is a maze, another maze. You answer the question like this. Um, let's see. You answer the question and then you just follow it. So this is the answer is 5 and you just follow the maze like that. Just like that. How are we doing? Oh, this one specifically is this book. Where are we? Um, that's this book. Cool. All right. Okay. And then this one is it has a color by number. So answer the questions, and then color it in. Here's the color key to help you. And then this is the maze. I added some word problems to help the children to review some word problems. And I try to make it traceable. I was thinking that the kids are young, right? I wasn't thinking that it'd be old kids. But I'm going to make one that's, for older kids. Here is find the hidden word, answer the questions, then you see the number, and then you match the answer to the words at the bottom, to the answer at the bottom, and then you'll figure out what the word is, and that's it. Those are all the activities. Oh, I also added a tic tac toe. Tic tac toe means you choose a box, answer the number, and that will be your place value. So here, this is O, and then there would be an X. So answer the question, and then that will be your place value. I was trying to make it a little bit more interactive than just a lot of monotonous questions. So again, there's the maze. This one was supposed to be roll the dice for some number bond fun. So the idea was to roll the dice. The dice is over here, and you were supposed to add the two together. And more word problems, and that was about it. I think that's it. I have a connect the dot, which is just you start from here and then you add. So 3 plus 3 gives you 6, and then minus the 5 will give you 1, and so forth. So the idea here was just to answer the boxes, connect the boxes, but in abacus questions. And the answer sheets are all in the back. So if you're a little bit lost, hopefully my answers are correct. So after minus 5, you go into, I'm sorry, after the plus 5, you go to minus 5. And you'll start to see the pattern. So when you notice, we're always looking at the add-in. So now we're at the minus 5. And at the minus 5, we're going to start with minus 4. Again, when we take away the 4, right, it's minus the 5 plus the 1. We've done it before. We added the 5. Now we're going to take away the 5. And that's what I showed you here, how to minus the 5. When we have 5, I want to minus the 4, right? To minus the 4, I want to minus the 5 plus the 1. Here's the question. Here's a sample question. If I have 8 and I want to take away the 4, to take away the 4, I need to substitute minus the 5 plus the 1. So my final answer is now 4. Huh, interesting. Cool. And again, it's very similar to understanding the number pattern, right? So when we add the 4, notice I add the 4, I'm plus the 5 minus the 1. But when I take away the 4, it's minus the 5 plus the 1. And it works exactly the same. So if we have 6, we have 16. There we go, 16. And I want to I want to take away the 4. There's not enough to take away the 4. I know to minus the 4 is equal to minus the 5 plus the 1. I'm going to minus the 5 plus the 1. And my final answer is 12. We could do it again. Right? So again, you notice that what we're doing is we're taking away the 4. This is the add-in we're trying to take away. So if I have 15 and I want to minus the 4, there's not enough. There's not enough beats to minus the 4. So what do? I minus the 5 and I plus the 1. That's what I did. And that's what the formula is. So the idea was, and then write the answer. This was a spinning paper clip. You take a paper clip and you spin it. And then wherever number it lands, then you put the answer to either evens or odds. That was the little activity that I have. This one was about how to find the different combinations. So how many petals are missing? There's one petal missing. So what's the partner of the 4 is 1, right? How many petals are missing? And then the partner is 4. And then which way are we moving? We're moving up or we're moving down. And then here is where we start doing the formulas. There's different ways to show what the formula looks like, and that's what it was. So it'd be minus 4 minus 1 equals minus 5, or minus, yeah. So, and again, the answers are in the back if you're unsure what I was trying to say. And then I have another tic-tac-toe and a color by number. The color by number, you just answer the questions and you color in the numbers. And then we have minus 3. And again, minus 3 is an add-in. Do we have enough to take away? So we go back to the question. Here's my question. I have 7. And I want to take away 3. To take away the 3, what do? I need to what? Minus the 3 is equal to, and I have to substitute it. Minus 3 is equal to minus the 5, and then add the 2. And my answer is 4. And we can do it again. So, and again, what it is we practice the same concept because we practice the same concept because once you understand this, it becomes very versatile. Let me show you. Let me give you a test. So here's my question. And you've seen this one. 1, 3, 5, 7, 8, right? 13,578. Now, what we're going to do is we're going to add. When we add, we want to add the 2. Is there enough to add the 2? Yes or no? Yes. Now we need to do is we need to add the 4. To add the 4, what do? Do you know how to add the 4? We know how to add the 4. Do you remember how to add the 4? Do you remember how to add the 4? We can add the 4. To add the 4, we're going to plus the 5 minus the 1. So look, we're going to plus the 5 minus the 1. And then what are we going to do? Can we add the 3? Yes, we can add the 3. 1, 2, 3. And then can we add the 1? Yes, we can add the 1. Can we add another one? Yes, we will add another 1. So this is my final answer. My final answer is 37,889. Easy? So what did we just do? We just compounded our information. What we just learned with the 5 is now scalable. And it doesn't matter how big the number is, as long as you understand the fundamentals. And the fundamental is what we were just talking about. Hello, Bentley. Thank you. Right? So this is too easy, Lynette. Yes, I understand. But this is the fundamentals. I don't know if anybody's watched Karate Kid, but it's like, with Karate Kid with Jackie Chan and Jaden Smith, right? Jaden Smith. You put the jacket on, you take the jacket off. It's the same thing with this. It's the same thing with this. When we're looking, right? Or even the old one, wax on, wax off. We understand the fundamentals, then we can go on. So here, let's do it again. We can do 26. 26. Now, in abacus world, we don't need to do friendly numbers. In abacus world, what we can do is we can use the formula. So here, we want to add the 3. Can we add the 3? No, we cannot add the 3. What do? We know how to add the 3. We've done this before. Add the 3 is what? Plus the 5 minus the 2. Well, let me do it again. Plus the 5 minus the 2. So if I have 2 on my abacus, and I only have 5 cents, I only have a nickel, 5 cents, I'm going to give you my 5 cents. But that's too much, so I have to take away 2. So it's the same thing. I give you my 5 cents, and I take away the 2. And then I minus the 2. No, I add the 2. When I add the 2, is there enough? Yes. So all we got to do is add the 2. So the final answer is 58. Yeah? Anybody have any questions? So this one is easy. Why is it easy? Because we don't need to worry about formulas. So if I have 2, 8, 3, usually in mainstream, right, we want to make these friendly numbers. But in abacus, we don't need to. Why? Because we can see our abacus whether or not we can add it. So if I add the 5, can I add the 5? Yes, I'll add the 5. Can I add the 1? Yes, add the 1. Can I add another one? Yes, add another one. So my final answer is 794. How are we doing? So after learning the minus, right? After learning the minus 5, do we have any questions? Any questions? Any other questions? Wow, I just like, hey, DJ. Good. Yes, abacus is easy. Simple to use, easy to understand. Thank you so much for commenting. I'm so happy, right? It's not difficult. As long as you can, right? As long as your mind is open, it's just a different way of thinking. It's just a different way of doing addition and subtraction, multiplication and division. So that was minus the 5. And then we can do, I still with you. Hey, X-Men! Maybe you can teach me how I'm supposed to under common core. Well, abacus is common core. If I really think about it, abacus is common core because it talks about what? It talks about place values and it talks about adding and subtracting. But the biggest thing about abacus is that we need to understand the fundamentals. And as you understand the fundamentals, right, then it can be scalable. So, but I don't in abacus we don't need to do the pictures, right? In abacus world we don't need to do the number bonds like was it I don't know 31 30 31, right? And we don't need to do 30 and 1. We don't need to do that because it's on the abacus already, right? So if I did 31, it's 3 and a 1. I don't need to show it on paper. The difference between common core, mainstream common core and abacus world is that on the abacus the abacus tracks your numbers, whereas common core you have to write it out. When you start carrying over, should you go from right to left? Right to left. Well, you you're always going to always go from the left, but you don't have to. In abacus world, I think we go from left to right. So we can talk about it. Let me do a question. So thank you, Jordan, for the question. So here is, let's do not this one. Let's do another question. Let's do 13. 13 minus 9. Why do I do minus 9? The reason why is because I want to know what it would, because it's a little bit easier. So I have 13. Notice I don't have enough beads to minus the 9. So when I minus the 9, oh, I get it. When I carry over, I'm adding. Yes, I would go from left to right. But we don't start. Do we start this way when we add? When we add? No, we don't. I always start from left to right. So even for this bigger number, right? Sorry. Sorry, I'm going all over the place. Let me recount. Let me rethink this. Here's my bigger number. If I have 3, 3, 5, 7, 8, right? And I did 2, 9, 3, 1, 1. So what would I do? I would do 1, 3, 5, 7, 8, right? I do 2, I do 9. 9 would be plus the 10 minus the 1. So that's what I would do. I'd still start from here. I'd still start from the left and I'd go to the right. But I know that when I read it, right, to do the 9, we know what? We know when 9, how to make a 10 with a 9. So if I want to make a 10 with a 9, I use the abacus formula. Plus the 9 plus 1 plus not 1, 9 plus 1 is equal to 10. So when I substitute it, right, when I isolate the variable, I'm going to go, if I need to substitute the 9, I will do plus the 10 minus the 1. So what I'm going to do, I'm going to plus the 10. There's a 3 here. Oh, plus the 10 minus the 1. Because if I add the 10, it's too much. So we have to do an exchange. We have to minus the 1. And then we have to plus the 3, plus the 1, plus the 1. So my final answer is 42,889. So this one is the same way, right? What am I doing? Oh, it's the subtraction now. Subtraction would be this, right? Subtraction is minus 1 minus 9 is equal to minus 10. So what are we doing, right? When I want to minus the 9, to take away the 9, what do I do? Minus the 10 plus the 1. What do I do? Because I've just isolated the variable. When I isolate the variable, what do I did? So if I have my question 13, right, I want to take away the 9. To take away the 9, it's minus the 9 is to minus the 9, right? That's what we're doing. Take away the 9. We want to minus the 10 plus the 1. We're going to take away the 10 and we're going to add the 1. So my final answer is 4. Did that make sense, DJ? And Jordan, did that make sense? I don't know how far you guys got with abacus. Angela, you okay? It's coming together. Yeah, as long as you're open to it, right? But the biggest thing is if you know how to add and subtract this, it's really quite interesting. It's really quite interesting. Well, we can do more if that's helpful, right? So let's start from the other one. Let's start from another one. We can start from 8. When we start from 8, here is the question, 8. If I have 4 and I want to add 8, well, guess what? There's not enough beads to add the 8. There's not enough beads to add the 8. Well, what happens? Guess what? I have a dime. I have 10 cents. I'm going to give you my 10 cents, but that's too much. How much do I exchange? How much do I exchange if I give you 10 cents? Put in the comments, how much do I exchange? If I give you 10 cents, which is too much, how much do I take out? Yes, 2. So I just take away the 2. So I add the 10, I add the 1, and I take away the 2. Exactly. Exactly. That's it. It's the same thing. We could do it again. If I give you 9, right? There's 9. 5, 6, 7, 8, 9. Right? 5, 6, 7, 8, 9. I have 10 cents, but I'm only giving you 8. I need change back. So I give you my 10 cents and I take away the 2. So then we're left with 17. I go to 10 cents and I take away the 2. My final answer is 17. We can do it again with another pair. right? We can do it again with another pair. Let's do 7. 7? We'll do 7. We'll do 7. 7, what's 7's pair? What's the pair of 7? 7 is 3. So if I have 9, I want to add 7. I only have a dime. I only have 10 cents. I'm going to give you my 10 cents, but that's too much. So well, how much do I come back? How much do I exchange it out? Right? If I have 9, I give you my 10 cents, but now that's too much. So what do? How much do I take back? If I only want to add the 7, how much do I take? 3. So I take away the 3. Exactly. Thank you, X-Men. Right? Thank you, Tracy. Hey, Tracy. Right? So when we're looking, now we're left with 16. And it's interesting. And that's it. Once you know how to add a 5 and you know how to make a 10, then everything under the sun you can add and subtract. It just depends on which way you're going. Right? So let's say we have 16. Well, let's say we have 16, right? And we want to take away the 9. We have 16 and we're going to take away the 9. We have 16 and we take away the 9. When we take away the 9, guess what? Minus the 9 is equal to minus the 10 plus the 1. Minus the 10 plus the 1. So my final answer is 7. Excuse me. Thank you for the follow, Shadow Milk Cookie. Thank you for sharing, Darren and Anna. Right? So does that make sense? So what are we doing? We're just understanding this concept. When we understand the concept of how to make a 10 and how to make a 5, right? Now we can do any adding and subtracting under the sun. And that's all I need. That's all I need. Yeah. How is it going, DJ? Yep. Are we all right? We can do it again. We can do 18, 1, 8, plus the 7. When we add the 7, that's not enough. There's not enough beats to add the 7, right? There's not enough beats to add the 7. What do? All we have to do is plus the 10, take away the 3. So we're going to plus the 10, and we're going to take away the 3. And our final answer is 25. You can do it again. See, it's just, and what it is now we start practicing and solidifying this concept, right? A lot about practicing. So we have 14, we have 1, and we have 4. We want to add the 7. To add the 7, there's not enough. I only have 4, right? There's not enough to add the 7. So what do? I need to plus the 10 minus the 3. So I'm going to plus the 10 and take away the 3. My final answer is 21. Yeah. How's it going, DJ? Does that make sense? Is that all right? Because I have sense. Right? Angela, are you okay? Anybody have any questions? Tracy? Clear. Thank you. Thank you. I appreciate that. Okay. We can continue on with we can continue on with what do you call it? Two-step equations. Are you ready for that? Laser focused. Very quiet. Everybody's very quiet, but I appreciate that. So what we're doing is we're going to go into what I call is a two-step equation. Two-step equation is a little bit more because why? Because now what we need to do is we need to understand, really solidify our understanding of how to add the 5 and how to add the 10. Now what we can do is in the final one is this two-step. So if we have the question 7 plus 7, when we have 7 plus 7, you'll notice that I have 7. I want to add the 7. there's not enough beads to add the 7. So we know the formula. We know what? We know plus 7 is equal to plus the 10 minus the 3. So I'm going to write it out. I'm going to write out 7 is equal to plus the 10 minus 3. I'm going to plus the 10. Miracle, you still here? We're going to add the 10. We add the 10. Now what do? We have to take away the 3. When we take away the 3, right, this is supposed to be a parentheses. When we take away the 3, what are we doing? Can we do it? Can we take away the 3? Right? Can we take away the 3? Whoops. Oh, great, Miracles. I'm so happy you're still here. Can we take away the 3? No, there's not enough beads to take away the 3. What? What is the partner of 3? Do you remember? The partner of 3 is 2. So what are we going to do? The partner of 3 is 2. We know that if we're going to take away the 3, we need to minus the 2 and equal to, I'm sorry, take away the 3, take away the 2 equals to minus the 5. Thank you. Yes, exactly. We want to add the 2. Take away the 5 and add the 2. Take away the 5, add the 2. And my final answer is 14. Why is this a two-step? This is what I call a two-step because we just take this information and we had to remember how to minus the 5. Minus the 5 is equal to plus the 2. Cool? Right? And then it gets exciting, right? Because now we know that we can combine numbers, everything you add and subtract is now scalable. It doesn't matter what it is. It doesn't matter what it is. There was this one person, they said, what was it, 9? What did they do? 99999. I think it was like what? 9999 plus 99. That's easy. How do I know? Maybe this is too much for everybody, but we'll see. The first thing we're going to do, hi Evie, thank you. 99, we're going to add the 9, right? We're going to add the 9. When we add the 9, is there enough to add the 9? No, there's not enough to add the 9. We know how to add the 9. Plus the 9 is what? Plus the 9 is equal to plus the 10 minus the 1. Or we can rewrite it, right? We could say minus the 1 plus the 10. Yeah. Now if you look, we're going to add the 9. To add the 9, we're going to minus the 1. That's what we do. Let's minus the 1 first. So if we're going to plus the 9, plus 9 is equal to minus the 1 plus the 10. That's what we're going to do. We're going to minus the 1. That's what we just did. And now we need to plus the 10. Whoa! Guess what? We cannot plus the 10. What is 10? 1, 0. 1, 0. 1. 1. Can we plus the 1? No, we can't. We know plus the 1 is equal to plus the 10 minus 9. We can rewrite it. Minus 9 is equal to minus 9 plus the 10. So we'll minus the 9 and then we'll plus the 10. What? We still can't do it. So you got to do it again. To add the 1, remember 1, 0, 1, 0. Can't do it. Minus the 9 and then plus the 10. So we're going to add the 10. Oh, we're done. No, we're not. Because we still have this one. So we're going to plus the 9. Can we add the 9? No, we can't. What do? Minus the 1 plus the 10. So we're going to minus the 1 and we're plus the 10. And that's it. That was really easy. 1, right? 0, 9, 8. Is that right? That's right. Is that right? I think that's right. Yeah, that's right. Thank you, Evie. Yeah, that's right. Because minus the 10, minus the 1, plus the 10. It gets a little confusing. Why? Because we've done so many things. Thank you, Chris. Yeah, I think that is right. So the if you look at it, we just needed to know how to make a make a 10, and then make a 10, make a 10. I mean, that's it. We just need to know how to make a 10. We need to know how to plus a 9 and plus the 1. If we know how to do that, then everything is golden. And that's how it becomes versatile, right? Oh, thank you guys so much for the hearts. But now understanding the fundamentals is become versatile. But what we did is now it's not like it's called a mixed, right? It's more than 2 steps. It was like 3 or 4 steps. But as you understand, right, is abacus for division? No. Abacus is not only for addition and subtraction. We can actually do multiplication. Let me show you multiplication. Let's do a simple multiplication question. I'll show you how simple it is. 54 times that by 24 times that by you. But the one thing is you need to know your multiplication fact. And that's what we're gonna do. I'll show you. Thank you, DJ, for the question. But yeah, let's do multiplication. So abacus can do multiplication and division. What are we doing? We're gonna do this one. All right. So the first thing we're going to do in abacus world is we're going to understand how many digits we have. So we're going to count. I'm going to clear my abacus. I'm going to count. 1, 2, 3, 4. Why are we doing that? The reason why is because we need to know where to put our numbers. And what we do in abacus world is what we do distributive property. It's called distributive property. So what are we going to do? Distributive property is an algebraic term. And what we do is we do this, and then we're going to do this. So let's start with 5 times 2 is equal to 10. So, oh, I'm sorry, 4. 1, 2, 3, 4. 1, 2, 3, 4. We're here. 5 times 2 is equal to 10. Add 1, add 0. Add 1, add 0. Don't forget the 0, right? Because 0 is still a placeholder. And then 5 times 4 is equal to 20. Add my 2, add a 0. Okay, we're done with the 5. I'm going to change to another color. Let's do brown. Let's do brown. So I'm going to readjust. 1, 2, 3. 1, 2, 3. I'm over here now. Now we do 8 times 2. 8 times 2 is equal to 16. Can I add it? 16. 1, 6. Yes, I can. And then what do? What's the next number? 8 times 4 is equal to what? 8 times 4 is equal to 32. Add my 3, add my 2. So my final answer is, what's my final answer? Who can tell me what my final answer is? What is this number? Anybody in the chat? What is this number? Yes, 1,392. Yep, 1,392. Thank you, Chris. Thank you, Angel. Thank you, Samantha. Hello, one tired mommy. Oh, thank you, Chris. I appreciate that. I appreciate that. Anybody have any questions? That'd be great. But it's also very easy to show on the abacus. It's very easy to show. That's why it's always good to understand how to read the abacus. You know how to read the abacus, then you'll be able to go through. You do all the calculations in your head. This is the calculations that you do in your head, but on the abacus, we can move the beads. So when we move the beads, it's easier to understand. Yeah? Great. If anybody wants like a worksheet, I have a reference worksheet. Where is my, yeah. So if anybody's interested, there's a link below that says Service Plus. Service Plus. You click on this and you can give me, you'll get a I'll give you a link for my worksheets. Oh, that's awesome. All right, cool. Math teachers with passion already. Oh, thank you, Chris. I appreciate that. I really do like abacus. I think it's the greatest thing next to sliced bread. It's the greatest thing next to sliced bread. Okay. So yeah. So what's the worksheet? It's a reference sheet. So this is the reference sheet. It's just to show you how to read the abacus on top of like how to use the abacus. So this is the workbook. The workbook is meant for preschoolers. It's up to you, but this one it was really geared towards preschoolers because I wanted to count forward and want to count backward. All right, but that's it. I mean, that's multiplication in a nutshell. I mean, obviously there's more, but that's really all it is. But it goes back to understanding, making sure you understand the formulas. So, anybody have any questions? Miracles, how are you doing? We could do another two-step. Oh, what was it? It was a carrying on. I think it was carrying on and regrouping. Let me see if I can find something. Um, okay, let's try this one. So we have this one. 73 minus 54. Now, when we're doing this, again, we're going to do 73. 73, right? Take away 54. Take away 5, take away 4. We're going to take away the 5. Can we do it? Yep, we can do it. We can take away the 5. So we're done with that, right? We're done with this. Now we're here. We want to minus the 4. When you minus the 4, can we do it? No, we can't. Minus the 4. Can we take away the 4? Is there enough beats to take away the 4? Yes or no? No. So we got to go down here. Can you take away the 5? No, we cannot take away the 5. So then we have to do this one, minus the 10. Minus the 10 is what? We want to do what? We want to minus the 4. Minus the 4 is equal to minus the 10 plus the 6. So minus 4 is equal to minus the 10 plus the 6. So we're going to minus the 10 and we're going to plus the 6. So my final answer is 19. 1, 9. This right here is what we call borrowing, right? Yeah, borrowing. We're only using this to borrow. Incredible. Oh, thank you. I appreciate that. Right? We don't need to do friendly numbers. We just need to know the fundamentals. We just need to know our building blocks. When you know our building blocks, then any question will be easy. We could do it again. Let's do another one. We can do 75, right? 75 take away 46. So we have 75, we have 70, we have 5. Take away 4. We can't take away the 4. Well, do you remember how to take away the 4? We know we could use the 5, right? Can we use the 5? Minus the 5 plus the 1. Minus the 5 plus the 1. That was a 5 formula, right? Now we're going to take away the 6. So we're done with that. Now we're going to take away the 6. Take away the 6. We don't need to do, what do you call it? Friendly numbers. We don't need to do friendly numbers. We just need to know how to minus the 6. So minus the 6. Is there enough beats to minus the 6? No. We can't do minus 5. So we have to go here. Minus the 6 is what? Minus the 6 is equal to, minus the 6 is equal to minus the 10 plus the 4. Minus the 10 plus the 4. So my final answer is what? 29. 29. Because what did I do? Minus the 6 is equal to minus the 10 plus the 4. It's a little squishy, but you know what I mean, right? What do we call that? That was borrowing. But now it can be agnostic. It doesn't matter where you are. It doesn't matter where you are. This one right here, we just did a plus 5 formula or a minus 5 formula. It doesn't matter where you are. It is now position agnostic. It doesn't matter where you are as long as you add the specific number. This number, right? Let's go back. So if I have 75 and I want to take away the 4, to take away the 4, what are we doing? Take away the 4, we're going to take away the 5. To take away the 5, again, right? We're not minusing it on the 1s, we're doing it on the 10s, but we don't need to worry about that. We need to worry about minus the 4. Minus the 4 is minus the 5 plus the 1. How do the abacus and money standards? What? How do use the abacus and money standards? Well, all it is, Jeremiah, is just that this would be the decimals. So this would be 300, no, 20, 35, 52. All money would be is just decimals. So abacus does decimals, if that makes sense. So this question right now is, I'm sorry, this number is 35.52. That's all it is. Matthew Longlegs. Ha, that's funny. Maddie. I'm sorry, Maddie, not Matthew. Yeah, right? So money is just means that there's a decimal and it only needs to do 2 decimals. That's it. Okay. How are we doing? And it's very interesting. Like it becomes very interesting like how much you just need to know the fundamentals and then everything would fall into a place. But you got to really understand the fundamentals. That's what this is. This is to understand the fundamentals. Oh, good, Angela. Thank you. Right? As long as you understand the fundamentals, then you can move forward. Yeah. All right. Anybody have any questions? Any questions? Can you show an extremely hard one that you can do? What? Multiplication or division or adding? I mean, yeah, it would just be more steps, really. Oh, thank you, Trinity, for the rose, and Chris, thank you for the rose. But yeah, I mean, like, are you talking about like a like addition, like a very complicated addition? I don't know how complicated it can be. I mean, really, can it be really that complicated? It can't really be that complicated because you already know everything. Whatever you like. Okay. Let me see if I can. Let me see. Let me see. I don't know. I gotta. Okay. Let's think about it. Um, how complicated would be? I don't know. Complicated would be what? Complicated would be. I don't know. Double digit? No. More numbers? I guess it would be just more numbers. Let me. Oh, you know what? Here, there. Got it. Got it. Here, let me do. This is not extremely complicated, but it can get a little overwhelming with the numbers. Okay, so here. 19 plus 82. There we go. There we go. 19. So what are we going to do? We're going to do 1 and we do 9. That's fine, right? Sorry. Let me rewrite that. So 19, and then what are we going to do? We're going to do 82. 82. Add the 8, right? So we're done with this. Now what are we going to do? We're going to add the 2. To add the two, what are we going to do? Well, remember when we add the two, is there enough beads to add the two? No. Can I add the 5? No. I need to plus the 10. How do I do it? Minus the 8 plus the 10. Minus the 8 plus the 10. I'm going to write it out. Plus 2 is equal to minus the 8 plus the 10. I'm going to minus the 8, minus the 8. I'm going to add the 10. Notice, add the 10. Add the 1, add the 0. Add the 1. Can I do it? No. I can't do it. How do I do it? To add the 1, is there enough beads to add the 1? No. Can I add the 5? No, I cannot add the 5. So I have to go here. I need to plus the 10. Plus the 10 to add the 1 is what? Plus the 10 minus the 9. So I'm going to plus the 10 minus the 9. So my final answer is 101. Is that hard? I don't know how, I don't know if that made sense. That's interesting. Okay, good. Right? Chris, you're so funny. Yes, hard. Jordan. It's not though. It's not. You know why? Because you know all the formulas that I just talked about. You know all the formulas. All I did was I just took it one number at a time. As I go through one number, have you just have to know when to start the new column. You start the new column when you're done with the question. That's a very good question, DJ. So here I have 19, right? Oh, I had 99. You only start the new column when you're done with the number. So if I want to add the 2, I need to minus the 8 plus the 10. Minus the 8 plus the 10. This 10 I'm still need to do. It's still the same step. So now I need to plus the 1 is equal to plus the 10 minus the 9. So I plus the 10 minus the 9. Can I do it? Yeah. So I'm done. Plus the 10 minus the 9. Now I'm done. Did that make sense, DJ? So you always have to follow the chain before you got to follow the chain before you go to the next number. Yeah. You cannot just be done here. You have to follow it through. You have to complete it. When you complete it, then you can go to the next number. Good. Good, Angela. Yeah. But again, this is very fundamental. You know how to add the 2. We talked about it. You know how to take away you know how to add the 1. We've talked about it. This is about adding the 10 and adding the 5. That's it. Cool. My OC doesn't like starting in the center of the. Oh, I you know, I don't know. If you think about it, it would be decimals or money. These would be like placeholders. I don't know. It's up to you. This one I got, but the ones I'm selling actually starts here. That's what I noticed. So I bought this abacus a long time ago. Actually, yeah, I got this abacus a long time ago, and then I started selling it. I noticed my indicators are actually over here now. So you have a place for decimals. Do you have to start from left to right, or can you go from right to left? You can go right to left. That's not a problem. Sometimes to keep track of where your numbers will land. So that's a very good question. Like this one question I have, I will go from ones. So there's a question. So this question, sometimes I'll go, I know this is my 8. I know I'll go here. 8, 7, 5, 3, 1. But because I've done this question so many times, I know where to go. So I could start from the center and never from the left. Unless you know, never from the left. You could start from the left if you know where your numbers are. So if you gave me the number 3,468, I know this is my 1,000. So it'd be 3,468. You can use the labels. Don't forget these are labels. So if you can read the numbers. So if there's no comma, right, then it'll be harder. Then I would go from ones to over through. But if there's a comma, then that helps me figure out where to put my numbers. Does that make sense? So like this one, right? 9,999. If I didn't know that that's 9,000, I'd have to count 1, 2, 3, 4. Or I could do 9,999. 1, 2, 3, 4. Right? That comma helps. The comma helps you figure out where you can start. You could start from left to right, or you can go from right to left. It doesn't matter. It doesn't really matter. It's up to your preference. Just like adding the comma, right? If we had 1893, we just write it this way, but we break it up. We know that it's 1,893. Doesn't matter. Doesn't matter. It's up to you. I just do it a specific way because I've just been doing it for so long. But I'm open to like new ways of, because it's only left or right to left. It doesn't. Yeah, it is up to you. Whatever you feel comfortable with, as long as you can keep track. As long as you can keep track of the columns, I think that's the biggest thing. Ah, can you add two digit with two digit from right to left? Yes. All right. So let's do 18. Let's do that one. 1981. Right? Okay. So 19 1. When we add the 1, what do we do? Plus 1 is equal to what? Can I add? I need to add 1 here. Can I add the 5? No. Can I add the 10? Yes. Plus the 10 minus 9. So I'm going to plus the 10 minus the 9. Plus the 10 minus the 9. I'm done with this one. I'm done with this one. Right? That's what I did. So now I'm here. Now I have to add the 8. Do I have enough to add the 8? I have a 5, 6, 7. No, I don't have enough to add the 8. So what do? I want to add the 8. So I got to go down here. Add the 8 is what? Plus the 10 minus the 2. Add the 8. 8. Plus the 10 minus the 2. Plus the 10 minus the 2. So my final answer is 100. To me, it's a little backwards, but that's only because I've been doing it for so long. Yeah. You could still do it, but it's just, I feel like you go one step forward, two steps back kind of a thing. Yeah. We can do again. We can do another one. Let's do 18. 1887. Right? I see if I start from the center, I would read my answer. If I started in the center, I would read my answer as 1, not 100. If you start from the center, like center, this would be 10. Here, we're a little bit off. If I start in the center, I would read, yes, would be 1, not 100. Yes. Because you have to look at that dot right here. So I have 18, so now I'm here again. 18. When you add the 7, right? We're going to add the 7. When we add the 7, plus 7 is equal to plus the 10 minus 3. Oh, that's just hard to see. Yeah. The screen's really small. If you had your own abacus, you could see it. And it's quite noticeable. Even with my old eyes. But yeah, the screen is very, very difficult to see. So then, and that's why I try to use markers. So we have plus 3, minus 3 plus 10, minus the 3 plus the 10. So we're going to add the 10. So I'm done with this. So I want to add the 8. Can I add the 8? Yes. I can add the 8. No, I can't add the 8. What do I do? Plus the 8 is equal to plus the 10 minus 2. Plus the 10 minus the 2. Plus the 10 minus the 2. So my final answer is 105. 105. Let's do it the other way. We have 18. We add 8. There's enough to add the 8, right? And then we add the 7. When we add the 7, when we add the 7, there's not enough. We don't have enough to add the 7. We know we're going to do this. So we're going to minus the 3 plus the 10, plus the 1 plus the 0 plus the 1. So now this becomes a two-step when we go over here. Plus the 10 is equal to plus the 10 minus the 9. Plus the 10 minus the 9. So then our final answer is 105. So if you go left to right, you have to go this. It just all depends. No matter if you go left to right or right to left, you're always going to get two steps. It just depends on what number it is. Hey, Jennifer, welcome. It's been a while since I've seen you. Did that make sense? One tired mommy, right? It all just depends. But you do have to keep track of. You do have to keep track of where the numbers are. Hello, Mr. Clean. Welcome back. Welcome back. Welcome back. Thank you so much for liking the live. Are you done with school yet, Mr. Clean? I was just wondering so my kids don't get confused from traditional edition. Thanks for the lesson. Yeah, not a problem, DJ. Not a problem. Yeah, one tired moment. You could go any which way. It is up to you. The only thing is you just got to track where you are. That's all. For the day or for the year? For the for the day. Cause don't you get out later? This is the last week for my kids. They're all having parties right now. Yeah. I was thinking like when are you done for the thanks? Um yeah. One tired mommy, did that make sense? Like it as long as they keep track of the numbers, it doesn't matter which direction. You just gotta keep track of it. That's all. This is our last week too, but we're gonna go work through the summer. This is my first time. Can you go over which columns or whether hey Jordan? Hey, yeah, not a problem. So what we're doing is when we read the abacus, right? When we read the abacus, it's 1, 2, 3, 4. Now, why am I here? Because I have this dot. There's an indicator. This is a label. This label is my ones place. So when I look, I have my ones, my tens, my hundreds, my thousands, my 10,000s. So when we look, 1, 2, 3, 4 is the same thing as 10, 20, 30, 40, 44, 144, 244, 344, and 444. And then we have 5. 5 looks like that. That's always 5. 5 is always this. 5 and 5, 55, not 10. That's 10. Why? Because it's a 1 and a 0. When we look, we have 5, 6, 7, 8, 9. And after 9, we have 10. 10, 11, 12, 13, 14. And every column is a place value. Ones, tens, hundreds, thousands, 10,000. Hey, Panda, welcome back. Woo! It's been a little bit. Jordan, did that make sense? So we can count, let's say this year. This year is 20,025. 2025, right? And then we can do 42,000, 42,025. And then this is the decimals. The decimals here are the tenths and the hundredths. So when we're looking, we have $1.15. That's what $1.15 looks like. Oh, thank you. It would definitely take practice to understand. It does take practice to understand. But if you notice, like every number, every column, you can only go up to 9. And so you can decompose 9999999. And then it is also very different if you have your own abacus, right? Because I can see it. I can see that there's an indicator. My my indicator's right here. So you could choose this one if you wanted to. It matters. What matters is what kind of question, what kind of number you're going to have. So here are my ones, my tens, but I have no more room for hundreds. However, now I have all this for my decimals. Midday mathers. Yes, Jose, midday mathers. So, and then this would all be my decimals. So it just depends on what number, what kind of abacus you're doing. Haha. 4 plus 3. Thank you. Thank you. Thank you. She has basic Pixar problems. Yes, thank you so much. 4. So I have 4 on the abacus. I want to add 3. When I add 3, what am I going to do? Well, if you noticed, let me rearrange this. If I have 3, I have 3 on my abacus. I have 3 pennies, but guess what? I only have 5 cents. Because I have 5 cents, I can give you 5 cents, right? What is the question? The question is 4 plus 3. So, 4. I need 4. 4. There's 4. So I have 4. I want to add the 3, but I only have 5 cents. Because I only have 5 cents, what do? I'm going to give you my 5 cents, but I have to exchange it and take 2 away. So I'm going to plus the 5 and then take away the 2. Thank you, Jose. Thank you, Panda. And my final answer is 7. Right. So, are there any other questions? Um, One tired. Mommy, are you okay? Do you have any specific questions or are you okay? Did that all make sense? Let me know. Okay. Let's see. Jordan, was that all right? Did that make sense? Oh, good. Okay. Angela, you're okay. Thank you so much, Angela. Yeah, make sense? Yeah, and I have the books that I have are very abacus driven, so they're very specific. Don't forget. Yeah, I gotta put in my video. You're right. I gotta put in my video. I stopped at the video. I will do it. I will do it today. I'll do it today. Um, yeah, yeah. Yeah. I stopped at the video and I was like, I don't know if my videos are good. And hi, Shane. I sent a request to our chair to add you. Ooh, you did. That's great. Thank you so much. I was just updating my website too with all of my books. I gotta do more. It's just so. Anyways, thank you. I appreciate that. Hello Shane. Welcome back. Welcome back. Thank you guys for joining. But I am going to be signing off. If there's any other questions, um, I was wondering for the charter. Do I have to sign anything? I know our homeschooler will love this. They're good. I bought them. Oh, I'm so happy that they're good, that the workbooks are good. Thank you so much. I appreciate that. I realized I was trying to be more like a standalone. That I hope that there's enough instructions. I hope there's enough instructions to understand the abacus. Oh, it's good to see you too, Shane. Thank you so much for dropping by. I appreciate that. Yeah, yeah. I don't know. I just wanted to. I'm still gonna. I'm gonna try to publish a book today too. I have to do a -10. And then I got to go on to the mixed numbers. And after the mixed numbers, I was going to go into some multiplication. Yeah, yeah, multiplication. Oh, yeah, I love it. Would the abacus help when kids are learning traditionally at school, or could it be it, or should it be kind of separate? In my opinion, Jordan, combine the two because the abacus is math. It is not an enrichment program. You are using manipulatives, right? Here's a question. Here is a question. You have manipulatives, right? What's the difference between these manipulatives and the abacus manipulatives? The difference is abacus is structured. You're not just given a hodgepodge of numbers and just kind of put it together. In abacus, there's a specific strategy. So there's a structure to learning abacus. Here is in abacus we learn how to add without the formula. Then we learn how to add with the formula, which is making the 5. And then we add how to make a 10. This is making the 10. And then is right here is what we call two-step, which means that we're going to combine the 5, how to make a 5 and how to make a 10 together. Can you teach me trig? Jaden? Jaden, you can DM me and I can tell you somebody else that can teach you trig. Right? So, yeah, it's interesting because abacus is very specific. And yeah, DM me and I can show you, I can introduce you to somebody who can do trig. Yeah, not a problem. Um But yeah, abacus is very specific. So if you notice some of the questions are, in school, the mainstream math is like, here, just do a bunch of questions. But in abacus, there's a pattern. And abacus, you'll see the pattern. So here is the adding of the pattern. This is subtraction, and there's a pattern. So if you notice, abacus shows that there's a pattern. So should it be separate? I don't believe abacus should be separate. I don't believe that abacus should be an enrichment program. I believe that everybody should learn how to use the abacus and how it's the greatest thing next to sliced bread. The reason why is because it helps you really make the concrete. I make the concrete in your head, as opposed to numbers. Numbers are really abstract, if that makes sense. Numbers are abstract, but the abacus makes it very concrete, like you know what you're doing. My kids are, and I think the patterns will help them more. Yes, yes. So when we're adding the 5, right, we have 4, and we want to add the 4, you'll see that there's this pattern: plus the 5 minus the 1, and then minus the 5 plus the 1, and then plus, you know what I mean? So you see a number pattern as well as as in the abacus itself, because even with even with these formulas, there's not a pattern. It doesn't make sense because you don't see it. These are still abstract numbers, right? And I always like tell you the number bonds. Awesome. I think it helped as a kid. I'm trying to get some for my kids to learn. Oh yeah. I have books, and I have books of abacus. And if you're interested in a reference sheet, I have a reference sheet that you can just. There's a link. There's a link at the bottom. It says service link. And if you click on that, you'll get, if you want to sign up for free worksheets. They can't make a 10 down at all. Oh, you know what? Oh my God. Oh, that's wrong. You know, they're going to have to know how to make a 10. So that's why this is really, that's why I have one specific book for how to make a 10. All of this is making a 10, and it goes through every specific add-in. Add the 10, add the 9, and then I give you numbers. How do you add the 9? And you just practice it, right? So here we have 4, and then take away 2, we take away the 2. We add the 5. When we add the 5, I'm sorry, add the 9, remember we add the 9 here, and I show you how to add the 9, and you just do it again, right? You do it again. Add the 10 minus the 1. That's how you make a 10, right? And we do it again. We do it here. So if I have 3 and I take away the 2, I want to add the 9. To add the 9, what do we do? Plus the 10 minus the 1. Plus the 10 minus the 1. That's it. And they keep practicing it, but it's very specific. And so then the next one is, how do I make an 8? And we do it again. How do you make an 8? Well, and they'll start to know that when they make an 8, they have to plus the 2 or take away the 2, and that's how you make the 8. And they'll start connecting between how to make a tens. Yeah, yeah. No, thank you guys for the questions. Any other questions? Um, But it's very interesting, like how everything just falls into place when you know the fundamentals. Hi, Yes, it's really quite interesting. It's very interesting. Oh, and so what's after like adding the four? You have to be careful. Why? Because the four can be two separate formulas. It can either be adding the 10, or adding the five, and then that's where you start going through the framework, and that's when you start going to understand the critical thinking. How do you make it right? Yes or no, yes or no, if you want to add the four. So if you add the four, because you notice, you might be wondering, well, do I do this one or do I do this one? It's always this first. If you cannot plus the five, then you need to plus the 10. That's the difference, and that's how you critically think. um and every question is, you have to critically think, can I do it? And that's always the question, can I do it? If not, how do I do it? Yeah. So that's why, like, 7 plus 4. So the question is 7, I want to add the 4. To add the 4, can I add the 5? Right? I'm sorry, plus the 4, can I add the 4? No, go down here. Can I plus the 5? No, go down here. Then I have to plus the 4 is equal to what? Plus the 4 is equal to plus the 10 minus the 6. Plus the 10 minus the 6. So you're going to know, one, the fact family of 4 is either going to be 6 or it's going to be 1. Yeah. Anybody have any questions? Wow, there's 48 people. It started off with like 5. I guess because it's dinner time for everybody. I gotta go. Okay, Mr. Clean. I see you in my next live. Thanks for stopping by. Thanks for stopping by. Have a good night. All right. I'm gonna head off. I'm gonna end the live as well. It's been a little bit, and I've been on for a while. So if anybody, I asked my question. That was it. What's your question? I didn't see a question. I'm sorry. No, do one more. Was that the question, Angela? Hi, I see. On your services. Oh, so I do have an online class. If you want to, it is a pre, what do you call it? It's the classes are pre-recorded, and it's up to you, and it goes up to your own pace. So I have one where I have an online class that it's at your own pace. I do have another one where if you want tutoring one-on-one, then we can talk about it. And you can email me. You can click on the service link, and I can let you know what my services are. So we could talk about that. Like, I'll usually provide a meet and greet to see if your child or you enjoy my personality, because not everybody, So and and then I have books, and if you want to do it on your own, that's fine too. I have books available if you want to go through. Yeah, but it all depends, like, how old the child is and so forth. Thank you, Jordan. Oh no, thank you. Oh yeah, thank you. Hi, Icy. Have a nice day to you too. Did that make sense, Angela? I think so. There's three ways, right? Either you can have my online class, which is pre-recorded. You can have a one-on-one, and I will teach, and it becomes custom, right? Or I have my books, and you can go through my books. And my books are structured to a point where you go one at a time. Like, I have a set. So I have my book 5, and then minus 5, and then plus 10, and then there will be a minus 10, and then there's going to be further on. Did that make sense, Angela? I'm not sure, but yeah. So those are the three: books, online class, self-paced, or one-on-one. Unless, yeah. So, um, do one more. Do one more. Okay, I'll do one more question. Do you have a question, Cornisha? Do you have a specific question? If not, I'm just going to do this one. We can do this one. I don't know how far you know, so we can do this one. 200, 283. And then what? 500. Add 5. Add 5. Add 1. Add 1. So my final question is 794. Yeah. Okay, great. Okay, Angela. Yeah, yeah. If there's any more questions, you can either email me, DM me, or and we can talk about it. Yeah, it always depends on how old your child is, or if you want to learn. So, because I talk differently. If the kids are like 8, right, they're not gonna go through preschool. All right. Thank you guys for joining. Thank you guys for the conversation. I do appreciate it. If there's any other questions, if there's no other questions, I'm gonna sign off. Thank you. Thank you. Yeah, if there's no other questions, I'm gonna sign off. Thank you guys, everybody, for joining. Have a good day. Have a good night. It's already nighttime for a lot of people. It's like dinner time for you guys, right? I'm in California, so it's still afternoon. Bye, X-Men. Thank you, Angel. All right, cool. Bye. Oh, I always forget.